right, 2.2, sampling techniques. In this section, we're going to talk about different types of sampling techniques. First of all, population. We need to understand what the population is. The population is the whole group of people or items being studied. So, for example, everybody in Canada fills out a census. The population is everyone in Canada. So again, when you take the whole group of people that you need to survey, let's say the whole group of our school, Streetsville Secondary, you can ask everybody in the whole group, and that's considered the population, the whole group, the whole people in the school. All the people in the school is considered a population. Now, a sample is any group of people or items selected from the population. So basically, from a population, you take a group from that population, and that's considered your sample. Now, a census, as I mentioned to earlier, is a survey of all members of a population. So in Canada, every 5 years, you would fill out a census. That census is every single person in all of Canada has to fill out the census. Let's look at example 1. And this is I took right from the textbook. I asked you to identify the population in each situation. Then indicate whether each researcher should survey a sample of the population or do a census. Explain. Now, a teacher wishes to know how early her students wake up in the morning. So, a teacher wishes to know how early her students wake up in the morning. Am I going to take a sample or am I going to take a census? So in this case, a teacher wishes to know how early her students wake up in the morning. Look at it. Is it easy for the teacher to ask everybody in her classes? Yes. Is it easy to record that information? Yes. Is taking a sample equally informative as taking a whole census? Well, that's a question that you have to then say, well, I'd say probably not, okay? Because everyone in the class could be coming from different areas, and because they're coming from different areas, they'll wake up at different times. They might have to come to school early because of badminton. They might come to school a second period because they don't have a first period class. So a lot of times this can become very, very confusing. So a teacher wishes to know how early your students wake up in the morning. Guess what, folks? We survey the entire population. Why do we survey the entire population? Well, it's her students, okay? And we're going to census the entire population, which is her students. We're going to do a census of the entire population. So we're going to ask the entire population because, to be honest, her students, there probably isn't that many, and she could collect the data pretty quickly and pretty accurately. So the because part here, folks, well, that because part is all up to you. That's right, it's up to you. You justify any way that you feel. You could say because it's easy for the teacher to collect the entire census, okay, entire data from all the population. You could say because it would not gather enough. It's not that onerous. It's not too hard for her to collect it. All of those things. It's important that you answer this question the best you can, but the way you feel would be important. And as long as it makes sense, it's a mark, folks. Let's look at another example. The principal of a school with 2,100 students wants to find out how much homework his students have each day. So, we need to identify the population, and then we need to identify whether a sample is enough or do we have to survey the entire population. So, a census, okay? So the population, obviously, is the students that attend that school, the 2,100 students. Now, are we going to do a sample or are we going to do a census? Well, 2,100 students for one person to go and ask all 2,100 on a given day is very hard and onerous. Also, not all 2,100 students will be present that day. due to sports, due to activities, due to early family vacation, whatever that may be, folks. But the idea here is that it's not that easy to survey 2,100 students. So, are we going to take a sample, or are we going to take a sample, or are we going to take a survey for the whole population, so a census? Well, hopefully you're thinking what I'm thinking, and you think a sample. Now, sample because it's very hard for one principal to gather information from 2,100 students in a given day, because not every student attends class every day, because there's bound to be someone who's absent, and we won't be able to record that information. So anything there would be acceptable for the because part, folks. All right. A clothing store needs to find out whether its customers are happy with its service. Now, think about it. Clothing store needs to find out whether its customers are happy with its service. Now, who's the population? Obviously, the customers at the particular store. So the store's customers. Are we going to take a sample, or are we going to take a census? A sample or a census? Well, folks, we're going to take a sample. Sample. Why? Well, let's see. Not everybody shops at a particular store every single day. Also, you want to be asking even new customers. They may be there today but not there tomorrow. So you need to be able to take a sample of your customers. Maybe, 10 different customers on different times of the day, every day for 2 weeks or something along those lines. It's very hard to be able to ask all your customers to respond to the survey. Also, you could say because the only people shopping there would be people who like the store. You could even say things like that. So you want to be able to ask a sample, which will be a truly accurate representation of the entire population. Okay, another one. A newspaper wants to know the public's opinion of a federal political party. So if you're not sure what I mean here, so federal political party, so that could be, if we're in Canada, it could be the NDP, the Conservative, or the Liberals, okay? Or if we're in the U.S., it could be Republicans or Democrats. So basically, a newspaper wants to know the public's opinion of a federal political party. So is this newspaper, think about it. Who is the population that they're looking at? So obviously, it's the country's population, okay? Not necessarily Canada, but in Canada it would be NDP, like I said, NDP, Conservative, or Liberal. Now, what would we sample the entire population, or survey or census the entire population? And hopefully you're thinking, yep, that's right, sample. I mean, who's really going to ask 40 of the 40 million people, all 40 million people? And they may not be home. You may be calling them. You might spend months calling them. So the idea is that it's a very large population. It's too hard to ask everybody. So therefore, we're going to take a sample to represent the entire population, just from different provinces. All right, moving on. When we take a sample of information to be able to survey to get that information, there are different types of sampling techniques. A random sample is a sample which all members of a population have an equal chance of being chosen. Simple random sample is choosing a specific number of members randomly from the entire population, i.e., a name out of a hat, or picking 200 random students from the computer. Okay, so picking random 200 students, or even, let's say, picking marbles out of a bag, things like that. All of those are simple random sampling. Now remember, a random sample is a sample which all members of the population have an equal chance of being chosen, and that's important. Everyone should have an equal chance of being chosen in order to make the sampling work really, really well. So there are different types. The first type is simple random sample, which I said basically picking names out of a hat. Another one is called systematic random sampling. So basically, when you look at systematic random sampling, you're looking at something that has a system. You randomly sample with a system in mind. So you're choosing members of a population at fixed intervals. So there's a system from a randomly selected member, i.e., you pick one person and then ask every 10th person before or after it. So systematic is to basically pick a person. Let's say over here. Let's say I pick this letter, and I'm going to check every 10th letter before or after, just to make sure that it is working, that the letters can be read. So I would pick the 5th one before this. That's an O. Then I go here and I pick the 5th character after it. 5, and here we go, that's a B. So the idea is that you randomly pick one person and you ask every 10th person before and every 10th person after that person. So let's say from a telephone book, and this is another example, the old style telephone books, where you can open to any page, pick a person from that page, and then ask every page 10 pages before it or 10 pages after it, you would phone call them. Now, another example is a stratified random sample. A stratified random sample is basically dividing a population into distinct groups. So stratified, we're going to stratify them into groups. So dividing a population into distinct groups and then choosing the same fraction of members from each grouping. So all right, a lot of times what I give you this example is, for example, the country, Canada. Canada, we're separated by provinces. If you take every province, and that would be the stratified part, is separating everybody by province, and then going inside every province and then asking 10% of the population in each of the province a specific opinion. So stratified is basically grouping them up first and then asking a percentage from every group. Another example of that is in classes. For example, there's so many grade 9 classes, or in a high school where we have 9, 10, 11, and 12. We're divided into classes. And by dividing everybody up into classes, you would ask a percentage from every class to represent the entire population of the school. All right, now another one is non-random sample. Now this one is a problem. Non-random sampling is a cheaper, more convenient way to sample. As a result of non-random sampling, a bias will occur. Now bias is an error that resulting from choosing a sample that does not represent the whole population. Now, this bias, folks, is very crucial. You have to limit the amount of bias in order to have accurately represented results. So, it is cheaper. So, for example, if an ice cream store wants to know what customers' favorite ice cream are, they're going to stand outside their door and check everybody's ice cream flavors and ask them that question. Well, the problem with that, again, it's convenient because you're asking in the ice cream store, but what's inconvenient is the fact that not everybody shops at that ice cream store on a specific day at a specific time. So it's really important that non-random sampling is limited if possible, due to the fact that there's a bias that occurs, and with that bias, it can really skew your results. Okay, moving on. Example 2. Identify the type of sampling in each situation and explain any bias that the sample could have. So, for example, the personnel department sends out questionnaires to 75 employees randomly selected from a list of everyone working for the company. So what kind of sampling is this? What kind are we looking at? So the personnel department sends out questionnaires to 75 employees randomly selected from a list of everyone working for the company. So you take 75 employees and you randomly select them and you give it out to everyone. Is this a simple random sample or something more concrete? So in this case, it's a simple random sample. Why is it a simple random sample? Well, because you just randomly pick 75 people from, let's say, a hat or from the company list. Now, a bias that could happen here is those 75 people are all friends, or those 75 people are all from one department, or those 75 people are only management. So it's very important that you're very careful and not to create a bias that happens like this. So if you're going to really do it to randomly 75 select it, it should be a representation of the entire population of that particular company. Let's look at another example. Here we go. B. A company randomly chooses one name from an alphabetical list of a store's customers, and then also selects every 25th person listed before and after him or her. Okay, so what kind is this? So a computer randomly chooses one name from an alphabetical list and then also selects every 25th person before and after that first person you selected. Well, it doesn't sound like it was put into groups, folks, and it isn't. What happened is you randomly pick someone from that list and you ask everyone every 25th before and every 25th after. So there's a system to this, and that's right. This would mean that this particular type of sampling indicates a systematic sample, random sample. Now, systematic random sample, for example, like this, you'd randomly choose that alphabetical list, well, every 25th person before or after. Well, what kind of bias could occur is, for example, maybe there's male and female that shop, and you only ask all females, or ask only males. So again, it can be difficult, and a bias could occur because it is influenced by a certain gender. Okay, next, what about another type? Well, the president of a bank interviews one branch's employees. Okay, so what kind could this be? Let's look at this. What kind could this be? Well, the president of a bank interviews one branch's employees. So let's say this president of this bank says, okay, I'm just going to stop by. Here it is, my local branch. I'm going to just ask everybody how they feel about the company. Well, hopefully you're thinking, well, that doesn't sound right. Kind of sounds he's a little bit lazy by just asking one branch. Well, that's considered a non-random sampling technique, and that's true here, folks. So here comes a problem. President of a bank interviews one branch's employees. What happens if that's like the branch that has the highest customer satisfaction? Well, obviously you're going to say our company is great because it has the highest customer satisfaction and everyone's happy. All our employees are happy here. But then you could ask another branch which has the lowest customer service, and those employees may not be as happy. So again, by just asking one branch, you're really creating a bias there and not really getting a true reflection of the company. Next one. D. The student council chooses a number of students from each class. So proportional. So one more time. The student council chooses a number of students from each class, a proportional number from each class. So they go around, let's say, to period 1 classes and choose 10% from each class in all the classes and ask the survey. What kind of sample is that? Is that stratified? Is that systematic? Hopefully you're thinking, well, everybody's put into classes, so that's a grouping. From a grouping, you're asking 10% from each group. So yes, that's right. This turns out to be a stratified sample. Stratified random sample. What could be a problem here is the 10% that gets asked could be all girls, 10% could be all boys, could be just the friends of the student council possibly. So it's really important that you don't create a bias that could create issues. All right, folks. Well, that's the end of the lesson. Have a numerical day.